So I want to return one more time to this model of the temperature in Chicago that we saw in a previous lesson. So one thing we might be interested in a model like this is intervals, so times when the temperature is above freezing or below freezing, right? Whether it's cold or not, essentially. So I've given you the same graph of this function, so you don't have to find these zeros in your calculator. I gave them to you down here. Notice, remember, the function is only valid for 0 to 12 because there's only 12 months, right? So we don't need to worry about this last 0 here. We're just going to worry about those first 3 because the model breaks down before we get there. All right? So when would we expect the temperature to be above freezing? Well, above freezing is 0, right? So above freezing would be T of x greater than 0, right? And we have to find these regions on the graph. Well, 0 is here. Greater than 0 is above the x-axis, right? So we really want positive y values. And that only occurs, right, from here to here. So that would be this region of the graph. Okay? So notice this, we would call this a positive interval, but it has an increasing and a decreasing part. My positive interval, I'm going to pick the x values. I'm going to say from 2.524, comma, 11.779. And I'm going to give these parentheses and not brackets because we don't want to include the points, right? Because the points are not greater than 0. The points are equal to 0. And then on what time intervals would we expect the temperature to be below freezing? Well, that is from 0 to 2.5, right? Because that's where my graph is below that x-axis. So this is, of course, T of x less than 0. And then there's another region too. There's this region, right? And remember we said that this last 0, it's not part of the model, right? So we're going to say instead of from 11.779 to 14, blah, 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 we're just going to say to 12 to the end of the year. Okay, so there's 2 negative intervals and only 1 positive interval. And notice that all of these boundaries, except for 12 because that's just the boundary of the model, but all of these boundaries are, besides that, are zeros of the function, right? So these are all x values where the function is equal to 0. That's really the most important takeaway here. So let's capture some notes, and then we'll consider this last question, which is kind of an interesting one. So graphically, positive and negative intervals have to do whether the graph is above the x-axis for positive or below the x-axis for negative. And the way we can write these down as inequalities is we can say f of x bigger than 0 or smaller than 0. And f of x, of course, refers to the y values of the graph. Now, the most important point that I'm trying to make here, and this is going to be helpful for both like writing these intervals down and in calculus next year, this is going to be our main idea, it's that the sign of these functions can only change at a 0 of the graph, right? So I can only go from negative to positive by crossing 0. And that's just a fact, right? You can't draw a straight continuous line from negative to positive without crossing 0. Very, very important fact when you get to calculus next year. All right. Let's consider this question here. Does our answer to the previous question change if we say freezing or lower? So this is almost just like a interpreting the words type of question. So freezing or lower would mean that instead of saying less than 0, we'd say T of x less than or equal to 0, right? So that means that now I want to include my zeros of my function. So I'm going to use brackets in my negative intervals instead to say that these points are included because they are equal to 0. The y value is equal to 0, I should say. So I get brackets here, and then 11.779 gets a bracket for the second one. 12, though, still gets parentheses because remember 12 was not included in the function at all. So yes, the answer changes a little bit, and it's because of this or equal to, the way we write down that inequality. We're going to continue to work on that throughout the practice. So, all right, let's look at a method now for finding these intervals without a graph. So to solve this inequality, so we have this greater than or equal to 0 is what we want here. We're going to use what's called a sign chart. Okay, I'm going to show you what I mean by that. This is pretty easy. So the first thing we're going to do, notice this is already nicely factored for us. The first thing we're going to do is find the zeros. So I have negative x squared equal to 0, 3x plus 21 equal to 0, and x plus 3 equal to 0. This, of course, just gives me x equals 0. This gives me 3x equals negative 21, and then x equals negative 7, and then this gives me x equals negative 3. My 3, 0. Okay, I'm going to plot these on my number line. So 0 gets a dot, negative 7 gets a dot, and negative 3 gets a dot. So this gives me now 4 regions that I can check, right? So I have this guy, this guy, this guy, this guy. Now, if I wanted to find the signs in each of these regions of this graph without graphing it, what I might do is I might plug these in to check, right? So any point in this first region, I can plug it in. They're all going to have the same sign because from our key takeaway, the sign can only change at one of these zeros that I plotted. So here, I might plug in f of negative 9. So I do on my calculator negative 9 squared, 3 times negative 9 plus 21. Negative 9 plus 3, multiply them all together, and I'm going to see what I get. And I get a surprisingly large number, but it's negative. That's all I really care about is the sign. So I'm going to label this region as negative. And if I plugged in negative 8 or negative 10 or negative a million, I'd also get a negative result. Then I'm going to pick a region, value from this region rather. So I'm going to do f of negative 5, although you could pick whichever one you want. I'm going to plug that into my calculator, and I get 300. Which is a positive number, so I'm going to label that as positive. And I'm going to keep going, right? So I can do f of negative 1 for my next region. And that gives me negative 36. So I'm going to label that. And then my last one, I can do f of 1. 1 is always a great pick because it's easy. F of 1 gives me negative 96. So again, I got a negative result. Okay, so if we want intervals where the function is greater than or equal to 0, we want just this positive interval. So that is from negative 7 to negative 3. And I'm going to give those brackets because we want to include the zeros based on the inequality sign there, right? If I wanted intervals where f of x was less than 0, that would be everything else. So that would be from negative infinity to negative 7. And here we have strictly less than, so I'll use parentheses. Not my positive interval, right? And then from negative 3 to 0. And then from 0 to infinity. Okay, so the steps to using a sign chart are as follows. So we're using a value in each region to test the sign after we've plotted the zeros on the number line. Now notice the sign does not have to change at every 0, right? So at this last 0 here, we went from negative to negative. You'd think, okay, there's a 0 there, so that means the function has to change signs. But what that actually means to go from negative to negative is at x equals 0, the graph just comes up, bounces off the x-axis. So it touches the x-axis but doesn't actually cross it. And that, remember, was the x squared factor. So that, watch out for that when you have like squareds in your factors, because the graph can then just bounce off the x-axis and not cross.